Okay. We Good news is we've already gone over part of this one. So, perfect square numbers are in this list. Perfect cube numbers are in this list. Okay. So, if I was needing the square root of 100 x squared, I would go to 100. That would be 10. And then I would go to x squared, and that would be x. See right here, there's my x, and right here, there's my 10. Then for the perfect cube numbers, let's say I had the cube root of 343 y to the ninth power. Okay? So I go to 343, and let's say that was negative. So 343, and it's negative. So that would be negative 7. Then I go to y to the ninth, and that would be x to the third power. Now with variables, that's kind of a nice thing, because what you do is that index number is a 3, so you put them in pairs of 3. 1, 2, oh, by the way, that's a y, so that should ought to be a y. There. Anyways, so pairs of 3, so 1, 2, 3, 4, 5, 6, and I'm putting an x. I know it's a y, but anyways, 1, 6, 7, 8, and 9. So there are 1, 2, 3 sets of 3. So that's how they do that. Okay? And this kind of explains it also. Now when it comes to just numbers, go ahead and just throw it into Mr. Goodbuddy. Now, if when you throw it into Mr. Goodbuddy and it shows up something nasty, like the square root of 24, which gives you 4.89879486, blah 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 blah. A lot of times it's going to ask for an exact answer. Well, guess what, bub? That ain't the exact answer. So what you got to do is prime factorization. And I know a lot of people do it the wrong way. 24 is 2 times 12. Don't just throw any number on the left. Throw a prime number on the left. So be careful about watching your videos, because some people will throw a composite number like 6 on the left. And I don't like that, because you lose numbers when you do that. So always make sure you've got a prime number like 2, 6, 5, 7, 2, 3, 2, 3, 5, 7, 11, 13. Put something that does not break down any further. Now, 2 also goes into 12. Then 6 breaks down into 2 and 3. Now, remember I said index number. You're looking for those number in pairs, those number of pairs. So I've got a pair of 2. Well, guess what? I don't have any more pairs. All I have are leftovers. So I really go back up to that number right here. I don't want to deal with 2 and 3. I want to deal with that number that gave me the 2 and the 3. So 24 is actually 2 square roots of 6. So that is your exact answer. Now, I've got a story and I'm sticking to it, okay? This prime factorization deal is kind of like this. They need work teams equal in number to this index number. So if they don't work well with anybody, they got to go back to jail for the day. So these 2 work well. So this work team gets to come out as a team called 2. And these scoundrels have to go back to jail for the day. And the first time I taught it that way, I turned around and just right in front of my face, not even 5 feet in front of my face, was a guy I knew had just gotten out of jail that weekend. So when he didn't even blink, I sucked in a good breath and I barreled on to the next problem. So, you gotta be careful about the stories you tell sometimes. Yep. So, this is pairs of 3. That's how many go in my work teams. So, divide by 2, and that gives us 125. And if you remember right, and if you're putting that check sheet in front of you, you've got a perfect cube number of 125. And that gives us 5 times 5 times 5. So I like our that little perfect square and perfect cube handout. Okay? So there's our work team called 5. And here's our scoundrel called 2. Now let's deal with our variables. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So here's our teams. 1 and 2 and 1. And here's our scoundrels. So we've got 2 teams of X's, 1 team of Y, and then our jail is a cube root, and then we've got an X and a Y. Oops, I forgot a scoundrel. So let me erase. There we go. A 2 and an x and a y squared. Now, how will we put this into our program? 5x shift 6 2, then a y. Then we're going to type in a times sign or an asterisk for times sign. Then the word root, parenthesis 3, close parenthesis, open, 2x shift 6 2, close parenthesis. Now that's a lot of stuff. A lot of stuff. Just saying. Okay? Now, 7 plus 6 is 13. 13 plus 8 is, 13 plus 8. I don't do math in my head. It's 21. 21 is divisible by 3. So, normally I would take and divide that by 2. But in this case, I'm going to divide it by 3. And that gives me 256. Now I'm going to divide by 2. And that gives me 128. And divide by 2. And that gives me 64. Hot diggity. I know that that is 4 times 4 times 4. Yahoo! I can deal with that. All right. Oh, whoops. Hang on just a minute. I was looking at cube roots. I need square roots. Durr. Let me change that a little bit. That is 8 times 8. Okay, now I can deal with that. So, whoops. Here's a pair. Here's another pair. And here's a scoundrel. So 2 times 8. Square root of 3. 2 times 8 is 16. Square root of 3. So how am I going to put that into my program? 16 SQRT, close it, or open parenthesis, 3, close it. Now, one more problem. I know that 3/4 are 75 cents. So there's my pair. There's my scoundrel. And then let's deal with the x's. Remember, when I don't see an index number, my index number is 2. There's my pair. There's my scoundrel. So my pairs come out. This 5 and this x. This scoundrel and this x go back in. And that, y'all, is chapter 1.6.